Lesson 8.1, Pythagorean Theorem. These are some reducing radical questions from yesterday. We'll look at them when I get back. The Pythagorean Theorem. In a right triangle, the sum of the square of the two legs is equal to the square of the hypotenuse. You will have to know which side is the hypotenuse. The hypotenuse is the longest side, which means it is always going to be opposite the right angle. So that is the first thing you have to figure out when you get to our homework for today. It is the side that is opposite the 90-degree angle, and it is usually labeled C. So here are some examples. What is the value of x? Express your answer in simplest radical form. So I'm just going to highlight the hypotenuse. Here's the hypotenuse, and then I'm going to write out Pythagorean theorem. So here's what that would look like. Opposite of side A is 21. Opposite of side B is 20. Opposite of side C is x. So I'm going to follow that. A squared plus B squared equals C squared, where C has to be the hypotenuse. So 21 squared plus 20 squared equals C squared. So I get 841 equals C squared. Then to get rid of the square, I'm going to take the square root. What I do to one side, I do to the other, and I get 29 equals C. So that means that our longest side is 29. The next problem, our hypotenuse is 20. So it doesn't matter which one is A and which one is B, so I'm just going to write it as x squared plus E squared equals 20 squared. And our hypotenuse is the 20. So let's simplify. X squared plus 64 equals 400. Subtract off 64. And we get x squared equals 336. To get rid of the squared, we're going to take the square root of both sides, and x is equal to the square root of 336, which is not a perfect square. So then I need to simplify like we did yesterday in the homework. So the biggest perfect square that I think of is 16, and I do that by using trial and error on my calculator. So that's 16 times 21. And 21 is a perfect square, so this reduces to 4 roots of 21. And yes, you do have to have it simplified in simplest radical form. That's why we did the lesson we did yesterday. This side proves the Pythagorean theorem. We will do this tomorrow when I get back. A Pythagorean triple means 3 positive integers that fulfill the Pythagorean theorem. So for example, 3, 4, and 5. 5 would obviously be my hypotenuse because it is the largest. If I plug these into Pythagorean theorem, this does hold, because I get 9 plus 16, which is 25, and 5 squared is also 25. So if we go back to the examples we've already done today, this is a Pythagorean triple because 29, 20, and 21 are all whole numbers. Over here we have 20 and 8, but 4 roots of 21 is not an integer or a whole number, so this would not be a Pythagorean triple. But the first example would. The legs of a right triangle have lengths 10 and 24. What is the length of the hypotenuse? So here's what my setup would look like. Leg squared plus leg squared equals x squared. So I get 676 equals x squared. Take the square root. and I get 26. So the question below says, are they a Pythagorean triple? So our sides are 10, 24, and 26. So yes, they are a Pythagorean triple because they are all integers. The question below, one length is the hypotenuse, a leg is 6, what is the length of the other leg? So remember, this 12 is our hypotenuse. So a squared plus b squared equals c squared. So I get 36 plus x squared equals 144. And now I have to solve for x, so I'm going to subtract, and I get 108. Get it in simplest radical form, so the biggest perfect square is 36 times 3, which gives us 6 roots of 3. So then this example would not be a Pythagorean triple. Converse of the Pythagorean theorem. If a squared plus b squared equals c squared is true, then they will be a right triangle. And then let me skip forward. Determining if it's obtuse. If c squared is greater than a squared plus b squared, then it's going to be obtuse. And if c squared is less than a squared plus b squared, it's going to be acute. So we are going to determine whether it's right, obtuse, or acute. So a triangle has a length 85, 84, and 13. So that means that the 85 has got to be the hypotenuse. That means it's the largest. So I'm going to do 85 squared compared to 84 squared plus 13 squared. And you have to do c squared first. So 85 squared is 7,225. And the sum of these two gives us 7225. So if we compare them, these are equal to, so what kind of triangle would this be? Right. And they asked us, is it right? So yes, because that holds. In the next example, 50 is going to be the hypotenuse. So we want to do 50 squared. 50 squared compared to 16 plus 48 squared. And we get 2,500 compared to 2,560. So this is less than that. So because it's not equal, it's not going to be right. But we learned already that if it is less than, then it's going to be acute. So if we had to decide, this triangle would be acute. Let's try a couple more examples. The triangle has sides 6, 11, and 14. So the hypotenuse is going to be the 14. So here's our setup. 14 squared compared to 6 squared plus 11 squared. You have to have that hypotenuse in the front because that's what our theorems say. So you have to have hypotenuse first, hypotenuse first. If it's greater than the sum of the squares of the legs, then it's obtuse. If it's less than, then it's acute. So here's our numbers, 196 compared to 157. So this is greater than, so it would be obtuse. The second example has a hypotenuse of 9. We have 9 squared compared to 7 squared plus 8 squared, which is 81 compared to 113. So 81 is less than that. So that would make this acute. When I get back tomorrow, I will go through some of the tougher examples, but you should be able to get a good start on the homework. Thanks for watching.